Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli the Computer Guy, and in today's class I'm going to be showing you how to name image files that your ArduCam is going to be saving to an SD card using a Unix timestamp. So in this particular project, we're going to have an ArduCam, we have our standard Arduino board that we normally use, and then we're going to be using an SD card, a data logging shield that actually has a real-time clock built in. So when the ArduCam takes a picture and then it saves that image to your SD card, we are going to be using a Unix timestamp in order to name that image. Why that's important is if you look at the default examples for saving images using your ArduCam, what you will see is that the image files simply iterate their name up from 1. So the first image file is named 1, then 2, then 3, then 4, then 5, then 6, so on and so forth. The issue that you run into, though, is every time you restart your little Arduino project, the ArduCam starts at 1 again and then overwrites any image files that you already have created. So if you have your little ArduCam in a project, it's going along, it's taking pictures for a day or so, there's some kind of power outage, something else happens, basically the Arduino project restarts itself. Well, guess what? Your ArduCam now is going to start overwriting all of those image files you have previously saved, which can be a big problem. So the nice part about using a real-time clock is what we can do is we can use that timestamp essentially to give a unique name to all image files. So even if the Arduino project restarts, it will simply be naming the image files based off of whatever the current Unix timestamp for the real-time clock is, so you don't have to worry about overwriting. And then the other useful thing is that you can then use that timestamp to know when pictures were taken. So using a real-time clock with your ArduCam project is useful in many fronts. It allows you to create unique names that will not be overwritten. It allows you to actually have some type of timestamp so you know when an image was taken. So overall, adding a real-time clock to your ArduCam projects is going to be very useful, and I'm going to show you how to do that today. Well, the warning for today is all the quirks we've run into up until this point using an ArduCam, we only add to with today's project. So I will say when you're going to go out there and you're going to start playing with an ArduCam for your Arduino projects, just, make sure to budget an extra few hours so that you can figure out all the fun quirks that are involved. So previously in a previous class, I've showed you how to save an image to an SD card using the data logging shield. And I've talked about how if you use non-standard compliant data logging modules, you may run into an issue with the whole SPI I2C communication protocol. And so that's one thing to be thinking about. So again, I'm using a hit Lego shield here. The nice part about this shield is it actually has a real-time clock built in, and the good thing about this is this uses all of the normal standards for SPI and the I2C protocol. I tried to use a data logging module that I've used for other projects, so I've used this data logging module for many other Arduino projects and never had an issue in the past. But one of the interesting things is because of how this deals with the SPI I2C communication, for whatever reason it doesn't like ArduCam. So essentially, basically, if you use a non-standard SD data logging module or shield, you might run into an error. Like the error that I was seeing when I use a non-standard, when I use this, was a FIFO length error. For some reason, something called the FIFO length was too long. It read it as being too long and it failed out. So I had all kinds of nasty problems trying to use this particular data logging module. Went to Amazon, bought this nice hit Lego module based off of the Adafruit design, and it works like a champ. cost about $7, and all my problems went away. It's one of those nice little credit card troubleshooting routines where, hey, you swipe your credit card, you pay $6, the problem goes away. It's very good. So the first thing to realize is if you're going to be using a data logging shield or a module, do make sure it is compliant and that everything works properly. If you are getting that FIFO length error where the FIFO length is too long, most likely you're using a module that is not compliant. So that's the first thing to realize. The next thing, just so you understand for today's project, is the shield that I'm using actually does have that real-time clock built in. I'll have a link to this in the doobly-doo. Again, it's about $6 or $7 for this particular shield. I've been using this shield for a while, and I have to say, I don't normally give reviews, but again, at least in the lab environment, I would definitely use this thing. The shield works very well, and again, that real-time clock function is nice because it's actually just simply built into the shield, so you don't have to add an additional real-time clock. The other thing, again, if you're going to be using a data logging shield, make sure it has the pins for the SCL and the SDA. They go all the way through. Some of the older shields do not have the SDA, SCL pins that go all the way through, and then you'll run into an issue that way. So those are some of the just generic quirks that you will run into using some kind of data logging shield and the ArduCam. Past that, one of the things that you're going to run into today is that the naming convention that the ArduCam can use for saving to an SD card is something called the 8.3 naming convention. So what that means is you can have 8 characters in front of your dot and then 3 characters after your dot, and essentially that's how the name has to look. So basically 1, 2, 3, 4, 5, 6, 7, 8, period, JPEG, JPG. Not JPEG, just simply JPG. And so this is going to run you into a little bit of a problem when you use a standard Unix timestamp, because a standard Unix timestamp is actually 10 digits long. So when you if you simply use the Unix timestamp as you pull it out of the real-time clock, it will be too long. And when the system goes to name the image file, it actually will save and name the image file, but you'll get a weird name instead of what you want. So what we're simply going to do is we're simply going to chop off the front 2 numbers. So it's going to be 15. So the Unix timestamp is seconds since like January 1st, 1970. So what we're going to simply do is we're simply going to minus off that first 2 digits, so the 1, 5, and then basically save everything else. So the final 8 digits, period, JPG, is what we're actually going to be saving as the timestamp. So that's just something to keep in mind if you're going to then pull the images into some kind of script that you've created on a server. If you want to do something like actually pull out the full Unix timestamp, you will have to add the 1, 5 back to the beginning of the image files, so that'll give you the full Unix timestamp. So that's just something to kind of keep in mind with this particular project. Again, the ArduCam with an SD card data logging shield is a quirky thing to work with if you're going to be dealing with this. Again, once you get it working, don't get me wrong, once you get it working, it works really nicely, but wow, you definitely want to make sure you have an extra couple of hours for troubleshooting if you're going to be trying to deal with this. So let's go over to the workbench. I'll just show you again how this is plugged in, and I'll show you a little bit about this particular shield. Then we'll go over and take a look at the code and show you how this works. So as far as build goes, there's really not much to this particular project. So basically you're going to be connecting the ArduCam just straight as the schematics show you from the ArduCam website. There's nothing particularly sophisticated here. The big thing is the CS pin. We have this connected to 7. We have this connected to digital pin 7. So theoretically the CS pin you could move around to a different digital pin, but at least at this point, don't do it. The ArduCam is quirky enough. Don't give yourself extra troubleshooting. Again, the big thing to remember if you're going to be using a data logging shield with the ArduCam is the new shields have the pins that run down to SCL and SDA, so therefore you can connect the ArduCam through the shield. If you get an older shield, it may not have those particular pins, and so that might run you into a little bit of problem. Beyond that, again, this is just the Hit Lego shield that I purchased. Again, I guess this is based off of the Adafruit model that was created. You have the full-sized SD card slot here, and again, you can just use a little adapter for your micro SD, so that slots in. The cool part about this is this has the real-time clock built in. So I've shown you the real-time clocks in the past. So again, you can have a real-time clock module if you want to, but this is another big old module to add on. What I like about this particular shield is it actually has the real-time clock already installed. One of the things that it'll tell you, if you purchase this particular shield, make sure while you're on Amazon to pick up some batteries. So you look at that little battery and you would think that you could just run to your drugstore or your grocery store or somewhere and just buy one of these stupid batteries. Apparently, there are a lot more of these tiny little batteries than I personally realized, and so this particular shield requires a CR1220 battery that the CVS's in my area did not have, the Rite Aids in my area did not have, the Walgreens in my area did not have, nor did the Giants in my area. Literally, my wife came out with me. She was like, oh, hey, if you're going to go to the drugstore, I'll just come along. And she was unamused when like 10 stores later, I came out and said, I still have not found the battery. So if you're going to buy this, you're going to use this. When you buy it, make sure to buy the batteries, because for whatever reason, at least in our area, they did not have these batteries just at the normal drugstore. So this is all that's required to set this up. You would slot the SD card in and then basically turn on the power and it will start writing to the SD card. So with that, let's go over and take a look at the code itself. So here we are. This is the sketch that I have modified. I will emphasize that I have simply modified one of the example sketches. Again, for the ArduCam, there is a lot that is required in order to make the ArduCam be able to do anything. And so I would not want to have to rewrite this code. Unless you want to be a hardcore computer science person or you really want to know the innards of the ArduCam, I would highly recommend whenever you want to do ArduCam projects, you simply grab one of their examples and then modify the hell out of it, because there's a lot of just nitty-gritty code in there. If you screw something up, it's not going to work. And so again, copy and paste. Professionals copy and paste. So for me, basically I have copied and pasted this ArduCam Mini 2MP plus multi-capture 2SD. This is in the example folder. So I've simply taken this and then I've modified it to allow the file naming using the real-time Unix real-time stamp. So with that, let's go down and actually take a look at the code itself. So the initial includes up here. So these are the standard libraries that are involved with this particular example. You have Wire, you have ArduCam, you have SPI, and you have the SD.H. The only library here that you're going to have to add additionally will be that ArduCam library. So you need to download that from arducam.com, install that into your Arduino folder, just like you do with normal libraries. Past that, we're then going to come down here. We're going to include that memory saver.h. This is the configuration file for the ArduCam. Not really sure why they do it this way, but they do. So you just want to make sure that within the memory saver.h you have configured the configuration file for whatever particular ArduCam you're dealing with. So we have the camera here. So it's I'm using the OV2640_mini_2MP_plus. So I have uncommented that out. And then the module that I'm using is the OV2640_cam module, and I've uncommented that out. So if you're using a different ArduCam and a different module than this, then you would simply comment out what you want to, or comment in or uncomment, I suppose. You would uncomment what particular device that you're using. If you're not sure, just do a bit of a search on ArduCam and verify what you purchased. Then we're going to go down, take a look at a couple of things. So basically we've got all the normal code here. We're not going to mess with any of that. This right here this is the CS pin I was talking about when I showed you the physical unit. So for the ArduCam, the default is digital pin 7. So remember, you can have multiple ArduCams connected to the same Arduino board. And so this is the pin that matters. They can share all of the other pins. The CS pin has to be unique amongst all all the different ArduCams. So this one is connected to pin 7. Theoretically, you could connect it to a different digital pin, but unless you really want to mess with something, just leave it at 7. The important one, you will notice the modifications that I've done within this code. I've simply commented out an ETCG note. So whenever you see ETCG note, these are the modifications that I've done. And so for this is the SD card CS pin. So the default for Arduino data logging shield is digital pin 10. So the Hit Lego shield that I'm using and the Adafruit shield that you could use uses digital pin 10. Basically, they use that in order to communicate with the SD card on the shield. If you are having problems with your particular sketch, just do a search and make sure that you're connected to the right digital pin. You've put in the right digital pin. For whatever reason, for this particular sketch, it defaults to a different digital pin. So again, you may have an issue there where if your shield uses digital pin 10 to communicate with the SD card, and instead, the sketch says digital pin 9 for some reason, obviously there are going to be problems. Then we're going to come down here. Again, here's a lot of code. Basically just copy and paste code. We're not going to worry about that. Then we're going to come down here to another ETCG note, and this is where we add what is required for the real-time clock. So we're going to be using the Rinky Dink library. It's simply called the Rinky Dink library. We've used it in a number of different projects. Download and install that library. We're then going to include that library here. Then we're going to call the DS3231. We are going to create a real-time clock. So RTC is then going to be connected to SDA and SCL, and this works perfectly for this particular shield. If you're using a different real-time clock module, you may have to deal with something else. Then we're going to come down. We're actually going to go into the setup routine here. Again, we have another ETCG note, and I'm simply going to do RTC.begin. So I am starting the real-time clock within the sketch. Do make sure you do this, or the real-time clock won't work. Past that, we're going to scroll down. Again, copy, paste, copy, paste, copy, paste, copy, paste, copy, paste. And again, like I say, as you can see, there's a lot of code here, and you don't want to have to write that. Again, you can go in and you can modify certain little things if you care, like what delays are or whatever else. But again, don't write all this out. Don't reinvent the wheel. Then we're going to go down to the loop. So this is the actual loop. It's going to just continue to loop through. And again, with all this is basically all just copy and paste. And this is how the ArduCam is able to take an image from the ArduCam, send it down to the Arduino, and then actually send it to the SD card. There's a lot of stuff here. Again, basically don't dork with anything unless you want to play and you want to be doing troubleshooting. All of this stuff, we just leave the hell alone. We leave the hell alone. All the way down to here, we have the ETCG here. Let me just type in that note. So I have the note, and this is where we are going to be creating the file name. So basically, with the initial code, there's a whole thing that says like K. Basically, it uses K in order to create the file name. So K plus 1 essentially ends up equaling the file name. I rip all of that out, and now I'm going to be creating the file name using the real-time clock, using the timestamp from the real-time clock. So the first thing that we're going to do here is we're going to create and call a variable called timestamp, and it's going to be a long variable. Remember, if you deal with ints can only be so large, and if you go above that size, you can run into problems. So we're going to be using a long variable type here, and we're simply going to be calling this timestamp. So timestamp is going to equal RTC get Unix time. So this is a function for the real-time clock. And then basically you just type in this whole thing right here, and what it does is it gives you the Unix timestamp. The problem is that Unix timestamp is going to be very, very, very long. And again, so it's going to be longer than that 8.3 naming convention will allow, right? So it's going to be 10 characters in front of the period. That's going to be an issue. So what we're going to do here is timestamp is going to equal timestamp minus whatever the hell this is. 15, what is that? That's 1,000 there. That's 1,000,000. So basically, we are going to subtract 150 million from the timestamp. What this does is all it does is initially simply removes that beginning 15. So what we need to do is we need to remove the first two characters from this Unix timestamp. So simply all I'm doing here is I'm simply subtracting by 150 million. When I subtract from 150 million, then it's going to strip off those first two numbers, and then I get the final number. return. So that's what we're going to be doing here, and that's why we do it. We just simply, so we know what's going on, we're going to serial.print line out the timestamp. So it's going to be that. Then what we're going to do is we're going to create a string. So we're going to string, the file name is going to equal, and so what we're going to do is we're going to turn the timestamp. So remember, this is a long, so we're going to turn that into a string. So the string function here turns a number that you give it into a string, and then we're going to concatenate on, so we're going to add .jpg. So basically, the timestamp number that's this is going to get turned into a string plus .jpg, and that's going to become the file name. We're then going to print out the serial print line out. So this is going to print out on the serial monitor, the file name, and then the out file. So this is the file that we're creating, is going to be sd.open, that file name. So the Unix timestamp minus 150 million plus .jpg is going to be that file name. It's going to write, create, or truncate. So basically it's going to overwrite. It's going to create the file regardless, and that is going to be the name of your particular file. And so that's going to be getting that Unix timestamp. And that's really all that's required to make this work. Okay, so let's connect the Arduino to the computer. Let's upload the sketch. So we're going to be uploading the sketch here. It takes a couple of seconds, and then once it's uploaded, we can go and we can take a look at the serial monitor. So the uploading is done. We can go to Tools, we can go to Serial Monitor, and we can see what it has to say. So one of the things, do make sure your baud rate for the ArduCam projects generally is going to be that 115,200 baud. So if you have it at 9,600, many projects you have this at 9,600, you may run into an issue. Do make sure you have this at 115,200. And then beyond that, we can go and we can just take a look at what the output is. So here we have the ArduCam start, then the SPI interface is okay, the OV2640 is detected, the SD card is detected, and so it's going to start capturing. And then here it talks about doing the capture. This is the file name. So basically this is the initial timestamp. So this is the timestamp with that initial 15 ripped off of it. So 90463,190. We then concatenate on the JPG. So this will be what the file name is. And so it's taking these pictures. It goes through, it tells us the total time required in order to capture a picture was however many seconds, and then basically it tells us what the FIFO length is. Again, if you're getting a FIFO length error, that is most likely a problem with your module or some other kind of connection going on, and then it goes through and it starts taking more and more pictures. If we put this onto auto scroll just to show you, when I pop out the SD card, you will get an SD card error. So that's where you get the file open failed. And so at this point is no longer able to save images because I pulled the SD card out. If we then go over and we take a look at my demonstration computer, I can then simply plug the SD card in. Once the SD card has been plugged in, it'll take a second for it to be recognized. Then I can simply click on the SD card, and there we go. See, I've got all of these image files with these names using the Unix timestamp. So that's 9046308. Then we can see this is 076, and this is 081, and that's 103. And basically you can scroll through and you can see that it's taking all of these different pictures using that timestamp for the name. And again, the valuable part about this is, one, if you add 15 to the beginning of it, you can simply run this through and figure out what the actual time and date this picture was taken. The other valuable thing is that this is a unique name now. So what I can do is I can simply pull this SD card out of my demonstration computer. I can then go back to my Arduino project, simply add the SD card back into my Arduino project. I'll hit restart just so it restarts, and then it will be able to detect the card again, and it will just continue capturing images to the card using these unique names, and I don't have to worry about the image files being overwritten. So that's just a basic overview of how you can use a Unix timestamp in order to name your image files using an ArduCam. I think it's a pretty interesting thing, and again, even if you don't care about the timestamp itself, this is a way to give all your images images a unique name so you don't have to worry about the pictures being overwritten. So there you go. Now you know how to use a Unix timestamp in order to give your JPEG images unique file names when you're saving them from an ArduCam using an Arduino. One of the really cool things about creating Arduino projects, and one of the most annoying things about creating Arduino projects, is that you can't take anything for granted, right? If you're using something like a Raspberry Pi, there are so many things already built into a Raspberry Pi, you don't really have to think about how things work. When you want to give files a unique name, you can simply use a function to call time, or you can do something else. It's relatively easy to make sure all of your image files get unique names using something like a Raspberry Pi. When you start to use Arduinos, though, remember, you basically have to build, or you have to add everything on that you're going to be using. Just using a basic Arduino, when you go to save a file and you have to give that file a file name, you really have to think about how you're going to name that file. Again, simply doing something like iterative increases, like you start at 1, and 1 plus 1 is 2, and 2 plus 1 is 3, and 3 plus 1 is 4, right? That might be very useful if you don't restart your Arduino, but as soon as you restart your Arduino, you're going to be overwriting all of the files that you've previously created. So you really have to think about how you're going to do something as basic as giving your files unique names. And so that can be an interesting thing for you to figure out in the Arduino world, and also it can be a very frustrating thing. I like using the simple real-time clock. So with that real-time clock, I am getting a unique value in literally every second, and so I can use that unique value to do something like give my files a name, and then beyond that, if I then want to know when an image was taken, I can then go and actually see when it was taken simply using that timestamp. So that can be a useful thing. So again, RealTime are really cool. They're great ways of adding the ability for your Arduino projects to take pictures, but you're really going to have to be thinking about everything that you do, everything from the I2C, the SPI communication standard, to how you're going to be saving the files onto your SD card, so on and so forth. It's a lot of stuff for you to be able to figure out, but it's quite enjoyable once you have done that. One thing I will warn you, if you're going to be buying the Shield, or if you're going to be buying any real-time clock, is again, do make sure to buy your batteries from Amazon.com or wherever you're purchasing them from when you buy your Shield or your module, because again, I just looked at this and I was like, oh, that's just a tiny little battery. I can just buy that at Walgreens or CVS or Giant or any of the other 10 places I went. And no, you can't. Apparently, CR1220 batteries, you can't find them at normal stores. So if you're going to buy a Shield or a module, just do make sure to buy the battery along with it. And then the final thing, again, the one quirk with saving files to an SD card using the Arduino is it uses that 8.3 naming convention. So you can have 8 characters in front, a period, and then a 3-character extension, and that's it. That's how the naming works. If you have 10 characters in front, it will still save the file with a file name, but the file name that it's going to give it is going to look quirky to you because, again, it's basically going to fail out and give you a different name. So just kind of keep that in mind. And so that's something you have to think about, again, with things like timestamps, is if you have a really long timestamp, essentially how are you going to chop off enough digits for that timestamp so that it saves properly? For me, basically what I found is if I simply subtract, I think it's 150 million from whatever the timestamp is, that by doing that chops off the first 2 characters of the timestamp, and then away I go. I can then use that timestamp as the naming. But that's something that you're going to have to be thinking about when you do a project like this. And again, what you decide to do, that's what you decide to do. So as always, I enjoyed doing this class and look forward to seeing you on the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.